Hello, and welcome to the Module 6 review video for STA 301. In Module 6, the big picture ideas are that we studied distribution shapes, then we moved into some famous named, discrete, and continuous distributions. We started off the module by reviewing distribution shapes that were first presented in Module 2. We reviewed right-skewed, where the mean is greater than the median, left-skewed, where the mean is less than the median, and approximately symmetric, where the mean is approximately equal to the median. We talked about the influence of the mean and standard deviation for bell curves. When we're thinking about a bell curve, changing the mean is equivalent to a horizontal shift. In other words, it affects where the distribution is centered, while changing the standard deviation affects the spread. In other words, the width. How spread out is the distribution. In other words, is the curve low and flat or high and skinny? We also talked about the empirical rule. The empirical rule is an approximation that can be used for data that is approximately bell-shaped, or in other words, distributions that are approximately normal. The empirical rule tells us the percentage of observations that will fall within 1, 2, or 3 standard deviations of the mean. The percentages are 68% of the values fall within 1 standard deviation of the mean, 95% fall within 2 standard deviations of the mean, and 99% fall within 3 standard deviations of the mean. The empirical rule is an approximation, so you should not use this if you can compute the probability directly. In other words, if you know information regarding the distribution, if you have the PMF or the PDF, you should not be using the empirical rule to estimate. We don't estimate probabilities that we can compute directly. A Bernoulli experiment is an experiment that has 2 possible outcomes that we typically label as success and failure. We first talked about a Bernoulli experiment back in Module 4. When thinking about a success does not always mean a good thing. It means the outcome of interest. And so just keep that in mind. In the context of probability, a success is the outcome of interest. Now, moving to famous named discrete distributions. The only named discrete distribution that we studied is the binomial distribution. Remember, it's important that you can recognize the binomial distribution conditions within the context of a particular problem. In the binomial setting, our experiment must consist of a fixed number of Bernoulli trials, where, as I just mentioned, a Bernoulli trial has only 2 possible outcomes, success or failure. All the trials need to be independent, with the same probability of success that remains constant from trial to trial, and in the binomial setting, we are interested in the number of observed successes. So in other words, our binomial random variable is the number of observed successes in a fixed number of trials. Hopefully you can see that based on the definition of that random variable that this is discrete. It's going to be a count. We explored the shape of the binomial distribution based on different values of n and p. I showed that through the binomial applet. You can find the link to that within the electronic version of the Module 6 notes on Canvas. I explained that when p is really far from 0.5, in the case of small sample sizes especially, the binomial distribution will take shapes that are skewed, either right or left. We talked about the fact that the shape of the binomial distribution will be right skewed if p is really tiny, in other words, closer to 0, and left skewed if p is really large, in other words, closer to 1. If p is decently close to 0.5, then you'll see a distribution that is approximately bell-shaped. We talked about how to use RStudio to find binomial probabilities. There are 2 main functions that you should use in RStudio to find binomial probabilities, dbinom and pbinom. I've included the syntax here on this review outline, and it's also on your formula sheet. When you are writing RStudio code on a quiz or an exam, you must use the right syntax. There's really no reason to use the wrong syntax because it's on your formula sheet. And so read carefully. Dbinom is equivalent to using the probability mass function. We use dbinom when we want to find the probability that our discrete random variable takes on a particular value. We use pbinom when we want to find the probability that our discrete random variable takes on a value less than or equal to whatever you plug in. This is equivalent to using the CDF. Pbinom finds cumulative probabilities from the binomial distribution. It's important to think carefully about what value needs to go into pbinom when you are asked to find a cumulative binomial probability. So once again, in the discrete case, you need to really think carefully about which value that you plug into pbinom, because in the discrete case, remember, the probability mass function is defined at specific values. Now, moving to the continuous side, we talked about two named continuous distributions. First, we talked about uniform. That is the simplest continuous distribution because its PDF is just a horizontal line. I can ask you to find uniform probabilities by hand or using RStudio. Finding uniform probabilities by hand simply involves finding the area of a rectangle, where we know that we find the area of a rectangle by taking length times width. When we use RStudio to find uniform probabilities, we use the punif function. That finds cumulative probabilities for the uniform distribution. So in other words, it finds the area to the left of whatever value that you plug in. Note the syntax. The min and max are the parameters for the uniform distribution. Those need to be entered based on the context of the problem. The parameters for the uniform distribution do not change based on the probability that you are trying to find. So make sure that you keep that straight. Remember, parameters are like DNA. They determine which particular version of a PMF or a PDF that you're working with, and you've got to get those right. Those are key identifying pieces of information. The normal distribution. Make sure that you are able to use R to find normal probabilities and values. There are two main functions that we used within RStudio in the context of the normal distribution. pnorm finds cumulative probabilities for a normal distribution. qnorm finds values. When you put in an area to the left, qnorm will give you the value that has that specified area to the left. Remember that the syntax here is that you must input the parameters, mean, mu, and standard deviation sigma for the normal distribution. Once again, you have this syntax on your formula sheet. So if you're writing an answer in terms of RStudio code, make sure that you get your syntax right. pnorm, in summary, finds probabilities. qnorm finds values. So when you're asked to work with a normal distribution, make sure you keep those functions straight. Also, in the context of a normal distribution, make sure that you understand what I mean by sketching and labeling a distribution. When you are asked to sketch and label a distribution as part of finding a normal probability, you must have the mean, the value or values, and the correct position or positions relative to the mean and correct shading. When you are drawing a picture to find a value, in other words, using qnorm, you must have the mean, the unknown value indicated, correct shading, and the shaded area labeled. Please be sure that you label values as values and areas as areas. So once again, make sure that you understand how to sketch and label a distribution. You will be asked to do that repeatedly on exam number 2. And finally, the standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. While you will not be required to standardize in the context of finding normal probabilities, the process of standardization is important, as you will see it again in modules 7 and 8. So once again, when you are asked to find normal probabilities, you must use RStudio code. You cannot do this by hand. You cannot use standard normal tables. You cannot use z-scores. You must use RStudio. And so once again, big picture of module 6, there are two key different types of named distributions, discrete and continuous. It's important that you keep in mind the nature of the random variable. Is it discrete or is it continuous when it comes to finding probabilities? We never change values within a pnorm statement or a punif statement because those are continuous random variables.